I built my first microservices at the Financial Times in 2013. That's it is a decade ago. And at the time, we were very early adopters. So we had to work out what it meant to build microservices. And often, if we had a problem, we had to work out how to solve that problem. It's not true of people adopting microservices now. This is the technology cycle. You have innovators when start using a particular process, and gradually you get more and more people moving over to it. Now, microservices are definitely in that late majority part of the curve. And there's also this technology hype cycle. When someone starts a new technology or process, they get very excited about it. Everyone's like, whoa, this has got so much potential. And then you start to hit the reality. And then gradually you get a more realistic view. So I don't know if we're still in that trough of despair with microservices, but I hear quite a lot of people talking about how they're not managing to make microservices work for them. So people are starting to say, oh, we should go back to the monolith. Maybe a modular monolith is a better idea. But I'm writing a book about microservices. I do think they can be successful. I think you have to focus on the organizational and culture challenges as much as you focus on the technology. And it's called enabling microservice success. So the first thing that I need to do is say, well, what is success? So what does a successful software development organization look like? And the answer is, it's one where you are enabling the business. Your job is to make the business successful. So the choices that you make should be ones that support the ability for the business to be successful. Accelerate is a great book. It is really focused on success in terms of business impact. They say that they define the performance of high-performing technology teams in terms of the impact on the productivity, profitability, and market share of the business compared to competitors. And the Accelerate metrics, which I'm going to talk about in more detail later in this talk, are focused on business outcomes. Can you release code more often? So everything there is couched in terms of the business. But the Accelerate research says these metrics indicate companies that are successful in enabling their business, but it identifies 24 key capabilities. It's very small, but what I want to point out is architecture is a small part of it. There are 2 capabilities that relate to architecture. All the rest of this, technology around continuous delivery, but a lot of it is process and culture. These are all things that the research says are important for being successful with an architecture style. So microservices are loosely coupled. You can make your own choices, so you're empowered as teams, but it's a small part of what you need to be successful. So Accelerate is about accelerating value. So regularly delivering real business value. If you can make small changes many times a day, then you can explore the market, you can react to events, and you can release features more quickly than your competitors. But this isn't the only aspect of success. And I've worked on systems that have been around for 5 years, 10 years. I've led operations at the Financial Times, so I have a list of other things that I also think are important. So the first thing is, can you adapt to change? Change is something that happens all the time in your domain, in the industry. So can your systems adapt to change? Can you maintain appropriate service levels? Is it easy to run your system in production, to know what's gone wrong and to fix it? Do you get to spend most of your time on meaningful work? Now, there's one problem that can happen when you have autonomous empowered teams, which is that everyone's having to solve the same problems. And some of those problems involve setting up infrastructure or monitoring, and it can be not that interesting to do. Not having to start again. Can you use this architecture to build a system where you don't have to stop and start from the beginning? And finally, can you keep in control of risk? Can you keep yourself in a situation where you don't have security risk, you don't have high costs, it's not operationally dangerous? So just want to quickly go through the pros and cons of microservices. So why would you choose them? Why might you not use them? There is no perfect architecture. You're always looking at balancing the context you're in with the things that the architecture offers you. And microservices are primarily a solution to an organizational problem. If someone is thinking of using microservices when they've got one team working on a system, it's probably overkill. You start to use them when you've got multiple teams working on the same system, and you're trying to work out how do you stop this team making a change and breaking something that the other team was depending on. So you don't want to have to communicate with every other team every time you make a change. Microservices is an attempt to solve that, because they should be loosely coupled. You should be able to define your microservices so that they have code that changes together, living together. And no other service accesses the data directly. They always come in through the microservice boundary. So they're loosely coupled, which means those teams that are working on different services should be able to move at whatever speed they want to. They don't have to check in. The developer experience can be quite an attraction for microservices because the build, test, deploy cycle can be really quick. You're not having to wait for someone else to release your code. You're not having to run all the tests for a massive monolith. You're running maybe a small number of tests. So it can be a really good developer experience. It is also a challenge. I'll talk about that shortly. It can help with compliance and security. So if you've got part of your system that takes payments or that has personal data, you can keep it very separate from all the rest of your system, and only that team needs to understand GDPR or payment card industry. So there's a protection there. You're stopping everyone else from making mistakes that could be costly. And let's face it, if you get things around security wrong, that can bring down your business. So it's important to try and mitigate that risk. This is a common thing people say with microservices. It lets you do scaling only where you need it. So you don't have to scale the whole system. You can just scale the parts that are under particular load. You can even shut down some parts of your system because they're not needed overnight. And in theory, that saves you costs. I'm not entirely convinced that for most companies that's really somewhere where you save money. But it's the reason why companies like Netflix adopted microservices. Increased robustness. You don't lose the whole system when something goes wrong. You lose some part of it. So when Elon Musk bought Twitter and got rid of so many developers and started randomly turning servers off, lots of things still kept working, but you'd see signs of part of Twitter breaking. So you wouldn't be able to count how many notifications you had. It would just show a flag that said, oh, there are some notifications. Lost the ability to tell you the count. So it was very robust to parts of the system failing so far. And there's flexibility. You can choose the tools that you need for your part of the problem. So when I worked at the FT, we wanted to model metadata. And metadata is really a graph. You have an author of multiple articles. Maybe you have two people writing an article. It mentions a company. There are some people working for that company. But we were trying to cram it into a relational database. That was really difficult, and there are questions you can't ask a relational database that you can ask a graph database. When we moved to microservices, there were things we could do that we'd never been able to do before. But there are challenges. There's estate complexity. So your software estate, the flip side of that flexibility is suddenly you've got a lot more things. So the FT went from having Tomcat and MySQL to having MongoDB, Neo4j. We'd have 5 databases. We'd have 3 programming languages. Suddenly there's a huge amount more complexity in everything that you do. And there's operational complexity. They're distributed systems, which means that things go wrong in the network or in DNS, and they break, and you have to work out where do you even look for the information. Finding the right granularity for microservices is a challenge because certainly initially everyone thought, oh yeah, microservices are small. If you've got hundreds or thousands of services, it's really painful to deal with that. It's far too many moving parts, and also they tend to have the data spread between services. So finding the right size, that's a challenge. It's taken people a while to get to. And if you have lots of microservices, any change, like let's say you need to upgrade a library or there's a security vulnerability, something like Log4j, if you've got 150 Java microservices, do you have to release a lot of services? Even if they take 5 minutes each, that's quite painful. And the developer experience is very different. So when I was first a developer working on a monolith, I wrote code, I checked it in, at some point it got released. Maybe I got asked about a bug. Moved to microservices, I'd be spinning up new servers. I had to understand infrastructure. I had to understand monitoring, because I was now setting up the monitoring. Suddenly I needed to be a lot fuller stack of a developer than I'd ever been before. And you have to learn a lot, and if you don't have the support, it's very frustrating. But the biggest challenge is organizational change. It's not just an architectural choice. You need to have different ways of working than you might have had in your previous setup as an organization, and organizational change is really difficult. So there's some conditions that I think you need to have in place to be successful with microservices. The first question is, do you understand your domain? Because when you try and split a monolith up into microservices, you've got to choose where those lines are. And if you don't understand your domain, it's very difficult to find that and get it right. So having that understanding really helps. So if you've built a system as a monolith and now you're trying to identify pieces you could take away as a microservice, you're more likely to be successful with that. You need to be thinking in terms of products, not projects. So project, you tend to get a bit of money to build a feature. You form a team, they build the feature, it goes into maintenance, gets handed over to someone else. For a product, you really are a team working on this product until it no longer exists. Team might go up and down in size, but you own the product and you own the outcomes. That is a little bit different for people who are funding this. They don't get to tell you what to do, they get to set you a direction. If you don't explain to your leaders what it is that you're doing in a move to microservices, you can find that you start making the change and it's taking a bit of time, and they don't understand why suddenly things are taking longer and why they're costing more. So you set up a microservice architecture, every team needs to support the systems that they own. Suddenly the company has to buy PagerDuty licenses for every developer instead of just the 5 that used to do support. That can actually be quite a big challenge. You need to have teams that want to be autonomous. If you're going to make design choices, if you're going to own your services and support them, you have to really want that. And your organization needs to be able to support that. So we found with the Financial Times that we had to change ways of working that affected people's jobs. If your job is to run the change advisory board, and we need to get rid of the change advisory board, that's a really unnerving thing, and that's difficult. And you need technical maturity. So sometimes I have a conversation with someone about adopting microservices, and they don't have automation, they don't have automated tests, they don't have continuous integration, continuous delivery. It's going to be really difficult to do that. There are things you should just get into place before you start thinking about it. So going back to those aspects of success, I want to dig into those a bit. So the first one, regularly delivering real business value. It's somewhere that microservices excel. It does support the ability to make a lot of changes. These first 2 metrics from Accelerate, short lead time. Lead time is between committing code and it being live in production. And a high deployment frequency. So you're making many deployments, which is actually a measure of how small your changes are. Because if you're releasing 10 times a day, each change is pretty small. Microservices lend themselves to this because you can make changes in each of the services. And this is a graph. I don't know if you can see that there are some blue lines on there. I basically graphed the number of releases we did a month when we were doing a monolith against the number of releases we did a month when we were doing microservices. So we would be lucky to do 1 release a month as a monolith. We'd do 200 with microservices. So that's a lot more business value. And 1 release a month, you couldn't really work out whether anything that happened to business metrics was down to a particular code change. because you might have 100 different changes in that release, and you can't really link that back. And if anything goes wrong, it takes ages to work out which part of this huge amount of code actually caused the problem. So back to those key capabilities. We adopted microservices. It helped us to massively increase the number of releases we did. But we also did most of the other things on here. It was all essential to being able to move fast. So having a lightweight change approval process in that it literally is peer review. Having a culture that rewarded learning. So Western organizational culture is about an open culture where you don't blame people and you reward people for sharing information. It's very fundamental. So change is something that happens. I think it's happening more, like the rate of change has increased, but you can expect things to change. Your organization changes, they have different aims in mind. Technology changes. Like a year ago, we weren't thinking about ChatGPT and what we might be using that for. You have to be able to respond to it. It applies to your organization and to the technology. Some of it is about changing business Okay. Sorry. Right. Change your business priorities. Yeah. So how easy is it to change, to explore new ideas for the business? And how easy is it to change priorities of what people work on? So let's say you have two teams working in microservices. One team has chosen to use Java and MongoDB, and the other team has chosen to use Node.js and Neo4j. But now the business says, actually, we need to move some people around and we need to set up a new project. That flexibility of technology choices now caused you some trouble because maybe people don't want to move from Java to Node, and maybe the middle team just doesn't know what to choose because they're made up of people from both. So there's an element with microservices where that flexibility, complete flexibility of choice, makes it difficult to respond to business priorities. Changing technology, that could mean things like migrating away from a key technology because it's being deprecated, and it could mean something as big as the move to the cloud. Microservices help a lot with trying things out, like a gradual migration. So if you want to try and introduce a new database or a new programming language, you can try it. You don't have to move everything, which is great. But the flip side of that is it can be difficult when you do need to make a massive change. So if you have to move away from your source control or something that affects everything, you've got to make that change in all of the microservices. But we really benefited from the flexibility to try things out when I was working in the FT, because we decided we wanted to try out Go, and it was as simple as, let's just spin up a service. We actually wrote a service in both Go and Java, and we compared them. We compared how long it took to write the service, we compared the size of the container images, and we looked at the performance in production. And it let us choose to move from then onwards to just using Go. We didn't migrate all of the existing Java services, we didn't need to, we just wrote new stuff in Go. And that's the power of microservices. And if software architecture is the stuff that's hard to change later, microservices is actually about change being a first-class design consideration. You're expecting things to change, so you're building an architecture where you can make change. But there is a problem, which is you need to be aware of the long tail. So all of those services that we wrote in Java, we didn't have to migrate. That's great. 5 years in, hardly anyone in the team's ever done anything on those Java services. In fact, most of them aren't really Java developers, they're Go developers. There's a risk there that you have to, at some point you have to say, is this still something we do? An effective organization needs to run software effectively, not just build it. Things go wrong in any production system. So the question really is, how successful are you at handling that? What kind of impact? Can you tell what kind of impact something is having? Can you quickly find the problem and fix it? And these are the these are the last two metrics for Accelerate: the low change fail percentage, short mean time to restore. Low change fail percentage. So how many of your changes have a problem where you need to fix it or reverse it out? And we found that when we started to release hundreds of times a week, that we had a much lower percentage of problems. And when problems did happen, we could fix it much more quickly because the changes were small. You could understand what was in the code that was going out. So we really benefited from microservices doing that. Optimizing for a short mean time to restore is a little bit more of a challenge because the good news is that the loose coupling in microservices gives you a small blast radius. You don't lose the whole system just because you've lost one service. But the bad news is that they're distributed systems. And I was just in Kevin's talk, and I'm using exactly the same quote from Leslie Lamport because it's great. It's basically distributed systems. Things go wrong, and you don't even know what's caused it. It's something you're depending on that is maybe several steps and dependencies away. It's a classic paper by Richard Cook about how complex systems fail. And it's not about software in particular. And it's actually about transportation, healthcare, power generation. Complicated systems, and distributed systems are complicated systems. And he says, well, you have to build these kinds of systems with multiple layers of defense against failure. And that's what we do in microservices architecture. So you build them with multiple layers of defense against failure, and you build resilience into your software architecture. And with microservices, this is important. So we use queues so that we're decoupling, creating messages and consuming them. We have multiple instances so that if one instance isn't available, we're able to go to the other instance. We have multiple regions. So we might have something running in the EU and the US. There's all of this reliability built in. But the challenge is then, how do you know when something important is broken? Because, first of all, huge numbers of microservices, huge numbers of checks. I actually checked in the FT towards the end of my time there. We did 10,500 checks. They were all set up, and they all ran every 5 minutes. It's roughly 3 million checks a day. So a 1 in a million event happens 3 times a day. So you can expect there'll be alerts that just were transient. You get this noise and you don't really understand what it means and whether it's important. But it's actually worse than that. Because if you set up your monitoring to monitor each of your instances, and that instance is down, the alerts will fire, but it's fine. It's actually not a problem because the other instance is there and it's working. So you have to think in terms of how do I know whether something significant has failed. So let's say both of those instances are down. Well, that might be okay too. Everything's in a queue. I can just wait for this to start up later. You have to understand the context of your system and whether that matters, that things are not being read off the queue right now. What we found was that you needed to focus on business capabilities. So you need to think in terms of what does the business need and is that working? So probably the simplest example is setting something up to monitor your homepage. So at the FT, we had something that hit our homepage and checked that you got back a page that contained some stories. Because it doesn't matter what's happening behind the scenes on that. As long as you get the stories, then we know that we're generally in good state. Some of our other business capabilities were a bit harder to do this. So we wanted to do testing of digital publishing. So a journalist writes a story and they hit a button. Does it appear on the website? So we thought, well, actually, what we'll do is we'll set up synthetic monitoring. So we had a service that ran end-to-end acceptance tests, fire off a publish request for a particular article, check that it got updated on the website. And it's incredibly valuable. If that test fails, you know you've got some real problem. And you know it much more quickly than if you wait for when a journalist actually publishes an article, because there are times of the day when they don't publish. You may not find out for quite a long time. But it meant 3 different teams having to talk to each other because there were people writing editorial tools, there were the publishing team, and there was the website. So it's complicated to arrange, but it shares an understanding of your business. On top of alerts, and you understand what's going on, things still go wrong. And the question then is, how do you work out what's going on? And monitoring is not enough. So monitoring is a view of the system focused on individual metrics, and generally it's quite good for doing things like checking a server. Like, is the server, what's the CPU load on this server? That's something that's a good and useful metric. But as applications become more complex, their failure modes do as well. So it's not something you can really predict, so you can't pick a particular metric and monitor it. So what you want to do is move beyond monitoring, and you basically go to observability. So observability is about looking at the external outputs and being able to infer what's going on in the system. And for a microservice-based system, the real measure is, can you understand and explain any state your system can get into, even if you'd never thought it could get into that state? So you want to be able to do this without having to write more code and deploy it. Don't want to have to add new log messages and ship it to be able to know what's going on. We found that tracing events through the system was super important. We actually just changed our logging to tag every log with a system identifier. And that meant that we could look at the requests going through a system and see, okay, which instances did they hit? Are we seeing a problem only for people who are going through this particular instance? Spend a lot of time just now talking about the operational side of microservices. And that's something that development teams probably do more work on than they do in a monolith. But I think that brings up the next question, which is, do you get to spend most of your time on meaningful work? And if your engineers aren't doing that, if they're not building things that are business differentiators, but they're writing another continuous integration pipeline because there isn't any shared code that they can use, it's not a good use of people's time, and it's also quite demoralizing. And it hits as your system gets larger, as it gets more mature. You start to get a lot of people complaining about workload. I can't write this new feature because I've got to go and upgrade this library in all of the existing systems. And autonomous teams have a lot of things to know about. So if you're doing, you build it, you run it, you know everything about your microservices, suddenly you have to learn a lot. When I worked on the monolith, I didn't have to know all this stuff. Maintaining microservices takes a lot of work. It feels a bit like a treadmill. And sometimes it's hard to, sometimes you can't make the case that you should. Okay, so sometimes you can't make the case to spend time on feature delivery. And product development teams can't be completely autonomous, basically. You do hand a lot of responsibility to your product teams, but you need to be able to help them. So the thing we found at the FT was that eventually you have to invest. You have to invest in tools that help everybody and in platform engineering. So platform engineering is something that people are talking about a lot, and obviously there's always been platforms, but the idea with platform engineering is that you're building something that all of the other teams can build on top of. So if you read team topologies, it talks about stream-enabled teams working on valuable product work, and then there are platform and enabling teams that sit underneath and support all of those teams. I really prefer to call it something like engineering enablement, because I think if you call it the platform engineering team, and Sam Newman wrote a blog post about this recently, people will think they need to build a platform, and I'm not entirely convinced that most organizations need a platform, particularly not a Kubernetes platform. I call it engineering enablement, and really it's about paving the road. So there are two aspects of this. You want to pave the standard path to production so that any new developer, any team can just use all of these tools to get their code to production, and they don't have to do things that are not about the business goal. The second thing is to make that paved road optional. And the reason to make it optional is because if you can't make people use something, then you have to build something that they actively want to use, and you have to talk to them. The other reason to make it optional is that there will be good reasons for people not to use it. That there will be teams that have needs that you don't have in your platform, and you should let them do that. You should let them find a way to go off the road. And there's a really great article from charity majors about the golden path. Same thing, the idea of how do you identify your set of software that you as a company provide to people. And some of the points about it that are really good is like you should fully support it. So people should want to be on your golden path, on your paved road, because they don't have to patch things, they don't have to support them. Things are done for them. It should be self-service, so that it doesn't slow people down. It should be well documented, so that people can find that there is something there that can help them, and it should be discoverable. So at the FT, we gathered together all of the stuff that supported our teams that were building business features, and we created a single place where they could go and search for any technology, and there would be libraries and examples and troubleshooting and easy ability to get started on that. For most of my career, the long term has generally meant someone saying, oh, this system's legacy, let's do a big bang rewrite. And, you know, that's costly. But without work, systems get messy. And someone earlier today, I think it was Michael, talked about entropy. Is like, basically things tend to get worse. If you want to keep your software system in a good state, you have to invest time in it. I think of it as like gardening. You need to remove the weeds. You need to tidy things up and cut it back. If you always focus on new features, you end up with something that no one understands and quite a lot of technical debt. And the decisions that were made or that someone else made 3 years ago come back and they turn out to be the wrong decisions. And that's the point where someone normally says, well, let's rebuild it. You know, starting again is very appealing. You get to maybe start on a brand new technology. Oh, I wouldn't have written this in Java. Let's write it in Go. And when you start on a new system, it's fun because there isn't a whole load of other code. You just start and make progress. And this is a reason why, certainly in the UK, lots of jobs say, greenfield development, you get to come and start again. And people really like that. Incidentally, this is the thing which made me realize Elon Musk doesn't know software. It was the point where he said, oh, we just need to rebuild it from scratch. Like, I can guarantee rebuilding Twitter from scratch is going to be a bad idea because it will take so long. And rebuilding stops you delivering value. It's very difficult to rebuild a system and still make changes to the existing system. And the evidence for this at the FT was that they rebuilt the FT website. It took £10 million, and it was 2 years of the existing website not getting a single new feature because they were building this really, really good website, but everything else just stopped. And the theory is that microservices should make it easy. They should make it easy for you to just gradually replace things. So you need to rewrite this bit of the system, fine. It's a service, you just rewrite it. You can write it in a new language. It should be, voila, it's there. But that's not always the reality. Sometimes the reason you need to rebuild the thing that you don't like is there in all of your microservices. Or you need to do something now that is something your architecture didn't allow for. And actually, it's very hard to fit it in. And recently, Sam Newman introduced me to this concept of habitability. So habitability is the characteristic of source code that enables people coming to the code later in its life to understand it. It's about understanding for change. Each software should be habitable because you always need to change software. So whatever your architecture, this applies. I think microservices support it more than some other architectures. But thinking in terms of, have I made this so that the person coming to this in a year's time is going to be able to understand it? And that could be you in a year's time. You come to it and you go, well, I have no idea what I was thinking when I wrote this. But it's important because the alternatives are really costly. And the final aspect I wanted to talk about in terms of success is about risk. You keep risk to an acceptable level. This is close to my heart because I ran the operations team at the FT, and I responded to operational incidents and security incidents. You can't remove risk. You can just take steps to try and reduce the chance of something bad happening. One of those things is to make sure that teams are not so overwhelmed with maintenance work that they can't take care of important risks. So one thing we had at the FT was that we did security scanning, which is great. We had security scanning in all of our build pipelines. but some library gets flagged up as having a vulnerability, and it's in 200 different microservices. There's suddenly a lot of security scanning alerts for lots of teams, and it can be completely overwhelming. We would have teams that would just say, well, look, I'm getting 200 of these a week. How am I supposed to do that and also do other work? So trying to remove some of that load from people can help them focus on what's most important. But the first thing around really handling risk, particularly with the microservice system, is about knowing your estate. Because you have loads of services, and you may not even know everything that you have in your estate. So we actually invested quite a lot in this. At the FT, we built our own system registry that contained information about all of our services. So it would say, well, this is written in Java, the repository is here, it uses this language, here are some troubleshooting steps. So we knew what we had. We could find all the things that were built using a particular technology or that were owned by a particular team. And that ownership is important, and active ownership is important. If something goes wrong with a service, you want the team that there's there to be a team that owns it, that would feel responsible for patching any security issues. It's really relatively easy to look at who owns a system when it's being built. The question is, 3 years from now, will you know who owns it? So we would tag all of our services with which team owned them and what level of service was expected. And we used that data to build dashboards that would show teams how their services were doing in production. So that encouraged people to fix up the data. If they saw something on the dashboard that wasn't theirs, they'd say, well, that's not my service. You'd say, well, okay, you need to move it to someone else. If you want to keep risk down, you have to be flexible on tech choices only when you need to be. So when there's a real pressing need for the team to do something different, they need a graph database because a relational database won't work. If you basically have a situation where the autonomy of a team lets them say, I'm going to write this in Kotlin, and now you've got Java and Go and Kotlin and Scala, it just is too much risk. So the paved road and standardization as a default helps you make high-level decisions around risk. And then you can choose other things, but you have to make a case for it. And that paved road should build in safety and security. Anything that's on the paved road should be patched automatically. It should be reliable. The default options should be safe. If you just copy this library or you copy this template and you use it, you shouldn't accidentally set up something that's using too many resources. And we also spent quite a lot of time creating guardrails for governance. So rather than saying, you must do this, you can't do this, we would say, well, here's what we expect of a system in production. So we'd have a list of things that people may not think of as part of the standard development process, where we'd say, well, have you thought about accessibility? Here's what we expect in terms of accessibility. Have you got releases being logged so that we know every single change that comes out of this service? Do you know what the cost is of running this service? And is the cost enough to merit having this service? Do we get enough value from this to even do it? And do we decommission it? When we get to the end of the life cycle, what do we do to shut this down safely and not still have a server running 3 years down the line because no one took the time to do the decommissioning? It helps you do the right thing. And the specific example for us, one example. So BizOps was our system registry, and we wanted every system to be in it. So what we had was a system code, unique system code that was generated when you added something to BizOps, and every AWS resource had to be tagged with a system code. Every log had to be tagged with a system code. So that meant you couldn't get to production without doing the thing we cared about. Log4Shell is actually a great example at the FT of where the investment we'd had in all of these areas helped. So we don't really use Java anymore, but there were lots of Java programs running still. But we were able to find them all because we could look at our estate and say, where is Log4j used in our GitHub repositories, link those repositories to the services, link those services to the team, and we could just say to everybody, here's your list of services that you need to go and check that you have upgraded. So People who'd chosen their own technologies had to handle it. Anything that was using the paved road, that was patched for them. It only took us a few days to sort this out, but it was because of all the investment that we'd done in knowing what we had and being able to call on people who knew that they actively owned these systems, even if they'd never deployed Java code before. So what next for microservices? Well, I think it's interesting. I think we'll see the last 10 years as the introductory period. We're getting to the point now where things have got a lot easier in many respects. And this article's from mid-2021. I think it's got a lot of good information in it. Points out that there are good frameworks for building microservices now. There's tooling for actually just writing the code. So that's great. OpenTelemetry is an emerging standard for distributed telemetry data that vendors are getting behind. This should make it easier to move from one provider to another for monitoring and observability, which has always been is historically quite difficult in a microservices system. At the FT, we didn't think of changing provider because we'd have had to upgrade so many different services to do that. But I think developer experience is the next challenge because there's just a sense that microservices are needlessly complicated for people. And Kubernetes is not developer-friendly. You end up writing a lot of YAML and having a lot of understanding about what's happening that maybe you don't really care about. You just want to be able to describe your service in some way and have it run and be configured to run on the platform. And lots of companies are investing in this. Companies like Airbnb and Shopify are building effectively tooling to make it easy for you to spin up a new service and to get everything set up correctly. So you have all of the necessary logging and monitoring. Backstage is something that Spotify have built, and it's a way of understanding your systems. So some of the tools that the FT had to build ourselves are now available. It's open source. You can configure it for your own system. And an ex-colleague of mine moved to Spotify and just said, there's so much complexity just abstracted away. I turned up and I just followed a set of commands and I was able to deploy a service to production. And that was something that had been more difficult at previous companies that she had been at. These tools are available. Developer experience is being taken more seriously, and I think that when I hear about companies that are doing well with microservices, they tend to be companies that do invest in that. So companies like Monzo, who have a very common, a standard template for any service. They've got thousands of microservices, but it's very easy to spin one up, but they all look exactly the same. It means they can move really fast. And this article is a fantastic summary of what developer experience is and why it matters. And one of the reasons it matters is for retention. Because, why would you put up with a poor developer experience when there are companies out there that are getting it right? They're expensive to hire people. Every time people leave because it sucks to do the work in your system, you have to hire again. So developer experience is an investment in getting good people and keeping them. So wrapping up, I think microservices are now a mainstream architectural choice. People who are very definitely late adopters of technology are starting to say, maybe I need to move to microservices. And there's a lot of tooling around it, but they aren't the only viable option, and there are lots of places where they're the wrong thing to choose. I do think fast flow of value is very important. And you need for that zero downtime deployments so that you can release at any point, and you need loose coupling so that you can work independently. That doesn't require you to be using microservices. You can use a modular monolith. Those two things, though, give a lot of value in whatever approach you take. And I think it's balancing up the reduced build and deployment complexity for microservices over a modular monolith and increased operational complexity. So if you have a monolith, you've got to run all the tests, or you have to identify which tests you run each time that you're building some section of the code. That's complicated. Microservices is a lot simpler. You run the tests for this service that is entirely separated. And also, you really find it a lot harder with microservices to just go around the API. You can't accidentally go straight to some code, which you can in a monolith. I think Autonomy is a challenge for teams. It gives them a lot to do, but it isn't about complete freedom. So I think there's this thing about autonomy is, hey, I'm autonomous, I can choose whatever I like. It's a responsibility rather than a benefit. And teams should feel, in Jason Yip's article here, he says that teams should feel authorized and expected to do what is necessary to accomplish the mission. So there's an expectation as well as a freedom to take steps. I do think you need some scaffolding. You need that platform, that paved road to assist people. I also think everything is a bit distributed now. I just don't think that you have that single monolith and the single database. So first of all, you're quite often using software as a service. So maybe you call out to someone else to do your authentication or to do payments for you. If you're using a cloud provider, you could be using other components that they provide. So maybe you're using a queue and using a database. None of our code is absolute. We're none of us executing programs on the same machine as the server. Most things are being served through the browser. So you have to deal with distributed systems to some extent, whatever your architecture. So I think you have to understand what happens in a distributed system, even if you're not using microservices. So everything's a bit distributed. As I mentioned at the beginning, I'm writing this book. If you are interested, the first few chapters are online, and you can read them for free. I think you can sign up for a free trial. And if you do, I'd love to get some feedback on it. And I have put the slides online, and you can contact me on those. Thank you very much.